Thank you so much, Gitte, and welcome to today's event about IoT Do-It-Yourself. The event is held together with Blue Fragments, and my name is Thomas, and I will be your moderator today. So for today's event, I found one totally awesome speaker, which is Torben Rauff. And a big welcome to you, Torben. Sorry, I'm being out of breath. I just had to run to the door to open it because of a delivery guy ringing the bell at just 2 seconds ago. But of course, a welcome to you, and also a big welcome to all of our online participants today. It's great to see so many being interested in something about building your own IoT stuff. So this is actually one of my personal favorites within the IoT spectrum, and I love to spend time building my own stuff, especially when I can include some of the kids actually. So, but for the session today, I know Torben have some really exciting stuff that we're gonna go through. But first off, Torben, we actually have known each other for a few years.
Yeah, we've been
we actually met the first time on a roof in Nørrebro. Remember that?
Oh yeah, and we were recording a video.
Exactly.
Yeah.
So we were hijacked to do a presentation about IoT and AI and what all of that could bring together. And all of a sudden, you and I had to come up with a script, a manus, and we had this guy filming us so we could do this awesome video about the event.
Yeah, and I was very focused about the breakfast because I booked a cheap hotel. Well, remember, I'm from the cheap part of Denmark, so I had not had any breakfast. So I had to do the script, and I always think, when do I get something to eat?
Yeah, exactly.
I don't hope that was clear during the video.
Yeah, I actually think it was quite a good video, and we actually ended up having a full house at that session. That was back in the days when we could actually meet in person.
That was in the old funny days.
Yeah, exactly. But Torben, I know that you of course spend a lot of time doing stuff like this, and also you have your own company.
Yes, I do that. The main part is that I'm lecturer at the Business Academy Aarhus, but also I have this company aside where, well, during the past years, it's mainly been the sensors part I've been focusing on because it seems like this is where people, they are doing software and so on, and then they forget about that the sensor is also quite important. So the sensor is actually normally the part which is the most exposed for environment and so on. It's drowned into liquid or hard wind or so on. So it has to be very robust, and people don't consider that when they do electronic, because electronic is well, not that robust unless that you pay a lot for it.
No. But yeah, so you have your own company and you work at a university. So how do you get the time for all of that?
Well, I think it's a good combination because as I need to prepare some stuff for the students, and what I do there when I do my projects is that I get inspiration, and also I think that I try to get the new knowledge. And also it's a challenge because when you do schoolworks, I have to be honest, when you're a teacher, you always think, oh, what I do is the most important in the world. But when you're out doing projects, you realize that there might be areas which you do not cope with your knowledge. And if you're only living in the university or in the school area, then you do not realize that you're not that clever. So I got a lot of defeats when I'm out there doing projects, figuring out that I'm not a clever man.
Sounds like you have a good bag of knowledge there, Tom. But I think we should actually get started. And it is possible to ask a lot of questions along the way, and I really encourage you to do it. You can choose to do it either by writing in the chat directly, or you can use Slido using code D411. And then after Torben's presentation, I'll make sure that they are all put together, and I will ask them to Torben. And Torben, with that, I'll give the word to you.
Thank you. So I'll see if I can do something. So I guess that Thomas already presented that we're doing this. And what we'll speak about is that, well, we have some values who has connected a sensor, but also that we do have a value and so on that don't mean that we actually are measuring the right thing. So what I want to speak about is that, well, we're having some output from our sensor, but what we actually measuring there. So also what I want to do is that I'll take you to a quick and dirty method to improve most of measure method results. So what you can do here is that I hope that you get a tool so you can increase the quality of your data and your measurement. So first about me, well, I don't think it's that important, but I'm lecturer at Business Academy Aarhus, where I do courses in programming and also embedded IoT. And then I have for, well, 10 years experience with their own business, and also I help students doing their own startup. And I've been working with the IoT technology for plus 15 years, and that's mostly for wireless systems. And then I do say that I have some key knowledge about implementing robust long-term operational solutions. So it's not only the laboratory I'm working. I think it's most exciting is that when you actually get the solution out there running, and not only up running, but also running continuous years for years. And also there's some references. This is the company where I have been working for, and also together with and doing some projects with them. And that's up for the agenda. Well, I thought that I had 1 hour, but I realized that actually I only have 35 minutes. So it will be very quick and dirty. And also the method that we are using will not be in deep because you can do a lot of choices and so on. So I do the quick and dirty methods, how to you do optimize your sensors. And what we'll do there is that we'll look at typical errors. And then we'll look at the 3 typical errors, which is offset gain and variance. And then finally, we'll do a summary. So I hope you agree about that. Well, if it's not, then it's too late to complain. Sorry for that. So first, I want to speak about today's topic, which is do-it-yourself. And of course, then we have to agree about what is do-it-yourself IoT solution and what is my perception of it. So we hope that you agree about that. But what I see there is that do-it-yourself IoT is often using very low-cost components because you're doing that for privacy, and maybe you do that for fun at your work, or you're doing some proof of concepts, or so. Well, for the first trial, you don't want to spend a huge amount of money. So that's why they often become very low cost. Also, that their time is not considered as a resource, it's considered as an experience. So when you do work around with it, when you do some fault finding, you don't count your hours because you think, oh, it's fun and well, it's not an expense for the company or yourself. So actually, time doesn't matter. And also what I see is that people, they put a lot of effort in doing the programming, also about the security, especially about the data security, because this is hype. You see it in the news every day that people has been hacked, and you have to be very keen on having the personal security due to the GDPR law, new law, and so on. And rarely they are any focus on the specific measurement. So they are doing a very secure data connection, they are doing an encryption and so on, and they spend a lot of effort doing that the right way. But about the measurement, well, they just connect the sensor and say, oh, now we have the measurement. But I want to argue about that. If you don't have the right measurement, then you don't have to spend hours for doing the security, because if your measurement is wrong, well, it doesn't matter that people actually hack it, because, well, the data is worthless anyway. So actually, that's my mission here today, to get you to spend more energy and focus about the measurement instead of the security. Of course, the security is important, but if you don't have the right measurement, it's not important anymore, because, well, if people hack something, they get the wrong information, then, well, then you have a small win there if you get hacked, because, well, then actually you mislead people. Also, what I see about the do-it-yourself solution is that the service and maintenance is not important, because, well, you have it on your table, maybe you have it on your company. It's not installed by a customer. So you don't think that it's a problem, because if it's broken, oh, we fix it, and even that's an extra bonus, because then you get extra experience and you get extra knowledge, because now you have to do some fault finding, and you during the fault finding you're getting new knowledge. But if you're out and doing a professional solution, then of course, if it's our customer, then the uptime is very important, because, well, customers, they don't like a thing are broken. So but this is rarely considered when you are doing those solutions. Actually, you're just waiting for them to fail, because then you can get to play with the stuff again. To the right, I have a picture of what I would call a typical setup for IoT do-it-yourself solution. You have a sensor, you have the 8266 small processor board. What I often use for communication is the MQTT protocol. I send it to a database, and then maybe I also have a Flask implementation, so it's online. It's a web site online. So that could be a typical setup. But again, my focus, that will be the little red device, which is actually the sensor. And again, I don't think there's any reason to do a lot of implementation about the MQTT, about the database, about the website, if the measurement is not correct. So again, this is the message for today. So maybe you already has guessed, but I think that the most important IoT component is actually the sensor, because it is the key to the data. And also, what you want for IoT is actually you want a picture of the real world. So, and the only thing which can measure the real world is the sensor, because the real world, sorry to say, it's analog. Even that we have those beautiful digital solutions out there, the real world is analog. When you listen to my voice right now, it's doing something with the air, which is then going to your ear, and this is all analog. So for getting anything to the digital world, we need an analog sensor. And what is a sensor then? Well, in general, a sensor consists of very expensive mechanical parts and then relative cheap electronic parts, of course, depending on the kind of sensor. But normally, if you look at the scale between mechanical expense and the electronic expense, you'll see that if you have a good sensor, then actually the mechanical part, that's the famous 80-20%. Here, if you do an IoT solution, you will typically look at, maybe you look at eBay, you look at Wiz, and then you get those awful sensors. When I say awful, I actually don't mean it's awful, because they are very good sensors, but the mechanical implementations is quite awful. I've been working in the marine industry, and where we did a test board with an Arduino board and a piezoelectric sensor, and it lasts for less than 1 hour when the ship was starting, because you have those vibrations, and it was actually just teared apart. So these do-it-yourself sensors is very good for testing in the laboratory, but out in the real world, I think that they will not last for very long, unless that you take some special concerns and build a special house for your sensor, but you rarely do that. So when you look at these sensors, normally what you do there is that you use a breakout, because this specific raw sensor element is normally not just aligned to connect directly to your solution. So what you do there is a breakout, which might be linearized, so you have the output which fit to a processor board, or you have a digital output. But remember that when you use a breakout, then somebody has been there and done something electronic, so they actually do something with the raw sensing signal, because that's normally the signal there is very low voltage, and you have to get up there. If you have a standard Arduino, then 0 to 5 volts. If it's one of the Wi-Fi modules, it's typical 3.3 volts or 2.8 volts, and you have to adapt that to the processor and to the sensor. So what we will look there is that you will use some breakouts where they're good breakouts, often expensive breakouts, and then the cheap breakouts, which is not that good often. So for now, we'll go to the measurement, looking at the error identification. So we'll look at the method that now we say we'll look into the sensor. So we'll take a look at what do we actually measure. I have here two different rulers. It's actually from the real world again. And you see, if you look at that, well, you can find the 2 ends at both rulers, but you don't know which one is actually defining the 2 ends. So you don't know if one ruler is correct and the other fails, or both rulers. So can you trust that ruler? So if you're doing a measurement, if you are doing some carpeting in your apartment or your house, and you use that for saying to the carpenter, oh, I want to order that, and you have to do a measurement there. So I guess that this shows the importance that you actually know that what you are measuring, you also need to be able to trust. So for that, for looking at the sensors, there we have some error patterns which can be recognized. So we just realized that for getting some useful data, we need to understand what we're measuring. Again, if you're looking at the ruler, there you're measuring, you know that you're measuring a distance, but you have those 2 rulers, and you can see that they are actually measuring different, but you don't know which one is correct, or both are wrong. That might also be. So how do we actually interpret the values from your sensor? So what we need there is that we need to define the kind of errors which can be there. So there is a small figure there. If you look to the right, there you have an offset. An offset error, that is actually you have a parallel displacement. So you have one curve there, and then you have actually the sensor value there, and you have a displacement there. And if you look at a curve, it would be parallel. Then you have a gain, which is at the lowest value, which could be 0. There, the gain error, that would be 0 because that's a factor you multiply. I'll explain that later. But if you look at the maximum output, there you multiply the factor and the gain error would increase there. And then also you have the variance. So if you do the same measurement for the same condition, then you also will have different results. So the displacement is what you see to the right in the low picture. If you look at the final 2 rows there, the 2 rows below, there you can see that actually you have one measurement, but you have different results. So this will be the error patterns. But how do we actually identify that? First, we have to prepare a measurement. So we have to create a plot so we get an idea of how is our sensor working. So what we do there is that we want the values to be measured as close to the source as possible, the source that will be our sensor. So we don't want to have 3 different measurement devices in between before we actually read our result, because for each time we do a measurement, we also add an error. Also, it's a good idea that actually you do read about your sensor, you get the data sheet and you see, oh, how is this? And also be aware that all the time, when you look at the errors, it's normally indicated as full scale, a percentage of the full scale range, FSR. This is because this is where you have the lowest percentage, and that's looking good at a sales sheet. So for reading the data sheet, there you get the first indication of how precise is your sensor. But if you are buying sensors at Wish and so on, well, I would not take that for granted. But of course, if you have a trusted provider for sensors, then of course you have some good information in the data sheet. That said, the very most important is that you have a valid reference. Again, look at the ruler. So you could see that they were measuring 2 inches each, but they have different values for that. So what you need there is that you need a certified reference there so you can trust. So if you only have one sensor, be aware that a sensor can never validate itself. So then you know you have a measurement, but you don't know if it's correct or it's wrong. Of course, you can see what is the variance. You also can see the offset, but you might not get the gain. So you can do something, only have one sensor, but if you have a reference, then you can do exactly how does my sensor work. Also, there's a picture and there's a reference for a white paper. This is from Senoy about a humidity sensor, and I think what is interesting there is actually the setup they made for doing the reference and calibrating the sensor. So what they have is that they have a reference sensor and they have the sensor they actually want to calibrate. And then they go to a measurement, which is called MSU data acquisition, and then they go to a computer to compare that. So you always need a reference for validating your sensor. So now we're going to plot the measurement, and I'll try to do some online here, if I can figure out to do that. So I prepared a small test here, and that will be a handheld video. So this is a pressure sensor. Well, this is a pipe with some water inside. Maybe you cannot see the water, but there's approximately 40 centimeters of water inside, and you see the 2 wires. That's because I have 2 pressure sensors inside the pipe. Here I have the measurements, and you can see they are quite close, 1.05, 1.06. And then there, if you look at the sensors, there's one with yellow wire, and there's one which is black. The yellow is a certified sensor where I know that this result actually I can rely on. So this has been tested, this has been approved, and it's certified. So I know that the measurement to the right, this is the correct one. And I can see there's a small variance or difference between the two measurements, but that could also be due to the multimeter. So what I can do now is that I can try to raise my sensors, and you can see that they are changing. So what I want to do, if I want to do a plot here, is that I would like to do a plot for every minute and so on, depending on the time constraint for the sensors. So also the response time for the sensors is very important. I have seen people who are doing a log and they are measuring every milliseconds and so on, and the time response for the sensor might be 2 seconds. Then it make no sense to do a very to have a sample frequency which is beyond that, because then you actually get the same measurement. So this is about how to do your plot. And then also I had another here. This is typical DIU do-it-yourself sensors. It's the DHT22 to the left and DHT11 to the right. So I have connected them to an Arduino, so I would guess that they would measure more or less the same temperature. I don't know, but I would expect that, because they are so close together that, well, they should be measuring the same temperature. We can see that later on. So this is the two examples where we'll go and see if we start looking at the DHT11. I have to share a screen for doing that, I guess. 1 minute. So this is continuous measuring, and what I see is that in the top I have sensor 1, 2, 3, and 4 there. I can see there's a difference approx 1.5 degree. There's 22 for this and 23.5. So there is a difference, even that they are located very close to each other. So I do not expect there to be 1.5 degree in difference between those sensors. So there is a difference, but I don't know which one is right. The first two, 1 and 2, that's the DHT22, and 3 and 4 is DHT11. DHT22 is more expensive, so that might be more trustworthy, but actually we don't know, because I don't have a temperature reference here, so I'm not aware which one is doing the right measurement, but and maybe they are all wrong. We don't know that.
Torben, you just need to presentation mode on your PowerPoint.
Yeah. 1 minute. So this was the measurement. And this was the two things that I want to see. So what we have here is that I have a plot here to the right. I have the calibrated sensor reference sensor, all the known values. this is only a plot for the unknown. And then also I have the IoT sensor output. So what I have done here is, this is the pressure sensor I have here for exposed for a level of 0 centimeters of water, and below I have for 10 centimeters of water. So what you can see is that measurement number 8, that is look like it's has a very huge variance distance to the other. So what I'll do there is that I software-wise would take that plot outside. So our method does not do that, but of course you can do that using an algorithm. And if you know the sensor then and the variance, then you can say, oh, if the variance is beyond that level, actually I'll just delete that measurement. And then for the 10 centimeters there, you can see you have a bigger variance. And what you would do there is that you'll do a linear regression and do an average calculation of that. So also when you do this measurement, you have to change the condition. So you should turn the power on and off. So your sensor are turned off and then on again, and see, does it actually give you the same value? Also, you have to do different exposures. Here I didn't do that, but in the pipe there, what we did there was that when we had the 10 centimeters, then we fill up a pipe for 2 meters, and then we go back to 10 centimeters and see, do we actually have the same measurement? So can it actually change the measurement range and go back again and still shows the same? And then also try to do some vibrations and so on and see, does that have any impact of the measurement? Of course, the sensor should show the same no matter what, but sometimes, especially if you do the different exposure, it has to find back to its original value, it will fail there. So you have to do a lot of measurements to get all that ideas what your sensor will, how it will behave. So now that I take for granted that we actually have the plot, what you do from the plot is that you do a linear regression. If you have that in a spreadsheet, then you can right-click on the diagram, and then you can actually just choose a linear regression if your signal is linear. We are only discussing linear regression here. Of course, if you have another, then you should choose that. But what you can see here is that you know the idle response because you have a reference, or you have made a reference in some way. If it's by water, then you can find the 0 degree by doing ice water, and you can find the 100 degree by having boiling water. So this is how you can actually do the plot, and then you have 2 plots, and then you can make a curve between that. So the offset there, you'll find that as the reference value minus the average value. You can calculate the average value by having, you always have multiple measurements. So let's say that you have 20 measurements, then you add the 20 measurements, and then you divide them by the number of measurements. Then you have the average value. You never trust only one measurement, because something could have happened just in the moment. Just like you saw in the example before, where we have this plot which was doing something wrong or something weird behavior. So by calculating the average, then you actually smoothen out the curve. So this was the offset area and how you identify that. Then you also have a gain error, or you might have a gain error. Of course, if you have a perfect sensor, then you will have no gain error. But the gain error, you find that by subtracting from the signal. You subtract the offset you just found before from the average, and then you divide by the reference. Then you get a percentage. And what you have there is that you can see you have the idle line, of course, that is what we want to. And then you have, when you have subtracted the offset, you have another curve where the error is 0 at the 0 measurement, and at the full range you have a difference there. So this is actually you always do it at the full range, because there you get the most precise value. There you have the full dynamic range. So this is how you find the gain error, and then we are missing one, and this is the variance. And of course, this is also, you can say, the most complex, because this is, if you have a normal distribution, then it would be the derivation. But what we do is that we calculate the root mean square, which is used to get a more accurate result for measurements, and can be used no matter if you know the distribution or not. If you know the distribution, you can get a more precise elimination by choosing the mean value, but I guess this is more or less a religion. I often fall back to use the root mean square, because then it can make a generic implementation, and I don't have to consider for the specific sensor. I can just use the root mean square. So the formula for a root mean square is that actually you add the squares of all your measurements, and then you divide by the numbers, and then you take the root square of that. The formula is below, and there's also an example. So what we find there is that we have all those measurements, and we calculate the root mean square to get a better value. We smoothen the signal, and we get eliminated the variance if it has a more or less contribution for a normal distribution. Finally, we can collect it all from the parameters. You have the offset, you have the gain, and you have the variance. So if you look at the offset, at the picture to the right, there you can see the offset is shown there. And if you go below, there you can see the gain. And finally, to the rightmost in the down corner, you can see the variance. Be aware that this curve is actually just a nonlinear curve, so it's not representative for a variance. That would be a plot, but consider that as a plot with a lot of dots inside, and then you have a variance for that. So for that, now you can have a final algorithm, and you can put that into the software. And if you do that, I'm sure that you'll get better measurements compared than if you just do a measurement and you use that value. So you can do a compensated. The compensated result would be the gain error multiplied with the root mean square minus the offset. So that should be the best fit for an ideal curve. So which we can do this quick and dirty. Of course, if your signal is not linear, if the offset, that might not be linear, the gain might also be, then we have to do something else. Then we have to do some more math. But for the quick and dirty method, I guess that this will actually raise the quality of many measurements. So to make a summary, I made a receipt here. So to improve your single data quality for errors, and be aware you have to do this for each sensor. So you cannot just say, like, now I take one DHT11 sensor, and then I make a fit, and then all other sensors will fit into that. You have to do that for every single sensor you have, unless that your supplier can guarantee that all sensors are within a certain range. But that's how sensors get expensive. That's when you want a provider or supplier to guarantee that. So first you need to find a valid reference. And if you're doing for a professional solution, that should of course be certified for some instance. Then you'll do a series of measurements with your sensor and also compare that to the reference. You do a plot, and from the plot you identify the offset, you identify the gain and also the variance, and then you do the common algorithm where you have the gain, you have the offset and the variance, and then you include that in the code. And I'm sure that if you try that at home or at your work, you have actually improved your data quality. To the right, I made a small implementation of the algorithm. So this is how it should be, or how it could be, not should be, depending on what you prefer. Also be aware that I do this calculation, I do that at the server side. So I have a religion there that the sensor data, I send them because I don't want to do a lot of data processing for the Arduino stuff or the 8266. I don't want to put a lot of processing load to that because, well, of course, the code language is that's C. If I go to the server side, then I can have a higher level language and it's more easy. And also what I do there is that if I send the raw data to my server side, then I can actually save the raw data. So if anything went wrong, then I can go back and find the source for my data and figure out what went wrong there. And maybe I did a wrong compensation. Then I actually can redo and still have the right result. If I do the processing locally at the sensor side, then I cannot redo the work I've done. Finally, there's a small appendix, and this is about the pressure sensor, which I showed you in the video. So, well, this is the criteria where we made this project. And, well, first it was a quick and dirty project where I said, well, we can do that tomorrow. But it ended up taking 2 years before we actually had the right, correct sensor range. So it's just that things that seems quite easy might be more troublesome. So I guess this concludes my quick and dirty method for sensing and do-it-yourself.
Well, thank you so much, Torben. It's been a true pleasure. And let me just share my screen here so that there you go. If you have any questions here at the end, don't hesitate to write them to us. But first and foremost, of course, thank you, Torben. That was a really interesting walkthrough. And I definitely learned something and also recalled some of my mathematics from my school. So we actually have a comment from Jan saying that it's also important to check the sensor's ability to correct for influences from other factors, e.g. the temperature is important to get a correct measurement of the water level.
Yeah, that's correct. Yeah, and there might be some self-heating in a temperature sensor. So also, what I forgot to mention is that this is the measurement you're doing today, but also sensors often do have a drift. So in 1 year, they will actually move away from the measurement. So there will be a drift. Normally, it's in the data sheet is also as a percentage. So if you have a sensor working out there for 10 years, which I guess is the normal period for an operational solution, there you have a drift at approx 2% typically per year. So actually in 10 years, worst case would be that you have a drift for 20%. So even you believe your sensor today, you actually have to do some calibrating. So there is a lot of maintenance for those IoT solutions.
Yeah, definitely. So we got a question regarding some of the hardware. So is Arduino a good place to start? Does it provide some sort of user interface to acquire the data, or how are you doing the data acquisition?
Yeah, I think for a place to start, Arduino is great. It's perfect because it's easy. There's a huge community. You can always find support if you have questions there. So actually, I encourage all my students to start with Arduino to get the initial understanding. And also, it's very easy to program and upload code. So it's very fast to get started. It's fast to do some replace code and so on. So actually, I will start with Arduino, but don't think that you can use Arduino out in an industrial application. But for lab work, the Arduino is great, and it has really done a lot for understanding at the university and so on, because a lot more students has now gained knowledge inside embedded than if we didn't have the Arduino platform.
Yep. Yeah, and I also know that you can say the entire IoT and do-it-yourself have actually moved into the schools, right? The lower class schools. And I know I was just out in my son's room picking up this one, being the Ultrabit sensor kit, which is a perfectly fine set of sensors, which comes with manuals and a lot of online stuff that makes it really easy to get going.
Yeah, and actually there's courses, there's our courses as well in Danish, and of course there's in English for microbit and ultrabit. I know it was BBC who originally did the invention, and they have a huge series of what you can do with that. And it's going from very basic to, I guess that they are also very complex solutions out there.
Yeah. I was actually trying to build a little watermill the other day with the kid. I didn't succeed in first round. But yeah, it's just to try again. So Jan is writing here, I have had good experiences with smaller ESP32 boards, which have Wi-Fi, creating the code and using the platform IO plugin. In the code, I submit the measurements using MQTT to a MQTT broker. Using Node-RED, I collect the data and store it in a database or show the data to a dashboard.
Yeah, and that's well, the ESP series 8266 is also now the ESP32 is very popular because, well, of course, mainly due to the pricing. In the start, the ESP 8266, it was awful, the documentation there. You had to guess everything yourself, but they have been, due to the pricing, so many have bought them, and they're starting out there to be some very good information. But I would never rely on that for a professional solution, because this is actually do-it-yourself stuff, and you're getting them from China. Not a bad word for China, but I don't see a professional series of the 8266. And also about the Wi-Fi connections, I know that many people are using Wi-Fi connection. I'm doing that myself, and that's again to what I said in the beginning, that do-it-yourself people actually they love when things are not working. But if you're doing a commodity solution where you have to hand that out to 10,000s of houses and normal people who are not interested in IT, then they get a new IP internet provider, and they have to change the SSID and so on. So things just get complicated when you are getting out of the lab or getting out your own house.
Yeah. So, but let's stick with that a moment, because Jan wrote that we have been using the Arduino for environmental monitoring for almost 4 years with no issues.
Yeah, of course, it depends on the environment. If it's just inside a living room, and so there would not be problems. But if you're out in the industrial area where, well, I said I was on board a ship when I was working with the refrigeration systems there, monitoring that, and there we saw, we do a quick and dirty setup for, we want to do some measurements, and we just do an Arduino because we can do that on site. But it lasts for 1 hour, then all the some components, especially sockets, they were teared apart.
Okay.
Of course, it could have been a bad Arduino, but I'm sure even you had a professional Arduino, they are not designed mechanical for doing that. But that said, the processor on the Arduino, that's also an industrial, you can use that on an industrial print, and actually it's open source, so you can have the print from Arduino and then you can change that to an industrial design. I've done that several times.
Yeah.
So it's not for Arduino, it's for the mechanical part that I would question that it can actually last for an industrial solution.
Yeah. Then we have a question from Nathan saying, what would be considered a quality supplier regarding sensors? Yeah, and maybe also what is commonly used for IoT in industrial applications.
Yeah.
So I'm also really keen on hearing that.
Yeah. Well, as I said, the past 2 years I've been working mainly with the pressure sensors. And there, in the start we said, oh, we have to, we use the pressure sensor for measuring the level of liquid. So we said, oh, you can have that if you go to Wish, eBay, and so on. People, they, especially from China, they will sell you a lot of pressure sensors for no, well, let's say $30, $40. And they are very good and for water and so on. But if you have, what we had there was that the liquid was ranging from acid to alkaline. And what we saw there was that the first year they were working very properly, but then the cable was attacked by the liquid, and actually we could just take out all the rubber from the isolation from the cable, and it was just down the tank, and we were not popular there because it was actually the food industry we were doing this. So
I actually can comment a little bit as well, because you can say I work with sensors every day, and we implement big IoT solutions for our customers. And one thing that we have learned in Blue Fragments is that it's really important to have sensors tested.
Yeah.
And even though that one sensor from one company is good, it's not necessarily that another sensor from the same company is good.
Yeah. And I think, well, I guess that the question was, how do you actually identify the good suppliers there? I'll say if you go with Omron, if you go for Siemens and, well, the well-known companies, the problem is that there you have to pay a very high price for the sensors. But also, if there's issues and so on, you know that they will actually...
So
problem.
What we often do is we accept that throughout the POC in the project, we buy cheap sensors. Just to get the flow running, to get things working, but always with the knowledge of that we know which sensors should we use when we go into production. And when we go out of the POC into the, you can say, the development phase, we will swap to the production sensors, so that we have the entire development based on the right sensors. Yeah,
and also for the matter of the pressure sensor project there, actually we ended up developing our own sensor in cooperation with a Chinese company, which were offering cheap sensors, and we said, well, this is not good enough, you have to do like this and this. And due to the corona, normally I would have been there and doing the quality issues, but we did a lot of mails and they did a lot of wrong deliveries. But we ended up having a sensor which now has been working for 5 years.
Yeah, there you go.
Yeah, but then, well, we had the price issue. Of course, we could buy the sensor from a Swiss company, but this was pricing, well, so much beyond that, well, the product would not survive if we had to buy that sensor. So we have to develop our own and then make the changes for the cheap sensor and actually instruct the Chinese company how to do it.
Yeah.
And of course, actually, they also ended up. We had a really good project. So also, of course, the Chinese. Don't be wrong there. They know something about production that we don't. So they are not stupid, but they know that we want to buy cheap stuff. So they are producing cheap stuff. If you want otherwise, then you actually have to tell them.
Yeah. All right, Torben. I think time is running out. It's been a true pleasure to have you here in the show. And if you have any additional questions, don't hesitate to reach out to us, and I will be delighted to forward the questions to Torben. And I think you also shared your email address in the beginning.
Yes, yes. And also, I do hope that the participators had either gained some knowledge or just had been confirmed that what they do is the right thing, because of course a lot of you are already doing all this stuff here.
Yep.